1, 2, 3, come on!
Good day, students! Welcome to Teacher Sally YouTube channel. This is Rosalie Custodio, your science teacher. Matter does not fall apart spontaneously except in very rare instances. This is due to forces acting at the ionic and molecular levels. Atoms tend to attain more stable states through formation of bonds. These atoms react chemically by losing, gaining, or sharing electrons. This results in the formation of ionic and covalent compounds. In this lesson, you will understand what is happening in the atoms during the formation of compounds and determine whether atoms transfer, accept, or share electrons to become stable. So without further ado, let's begin. In today's lesson, you should be able to identify the relationship among the number of valence electrons, electronegativity, and ionization energy, and identify and describe ionic and covalent compounds based on their chemical formula and chemical names. In this part of the lesson, let's try to find out what you have learned on the previous topic that will help you understand chemical bonding. The periodic table is a list of all the known elements which are arranged according to the similarities in their properties. On this slide, there are 5 elements to be identified as metal, non-metal, or metalloid. Silicon is metalloid. What are metalloids? Metalloids sometimes behave like metals and sometimes like non-metals. Francium is metal. Scandium is also a metal. Which side are metals on? Metals are on the left and in the center. Krypton is a non-metal. Which side are the non-metals on? Non-metals are mostly on the right. Next, let us identify the names of groups in the periodic table. This is the alkaline metals, alkaline earth metals, transition metals, halogens, and noble gas. Lastly, valence electrons. Do you know what valence electrons are? Valence electrons are the outermost electrons of an atom. We have found out that elements belonging to the same group have the same number of valence electrons. Valence electrons are the ones in forming bonds to form compounds. Knowing the number of valence electrons will help you illustrate how bonds are formed. Great job! You can still recall your previous lessons. This time, you will be introduced to some basic concepts such as strengths in the periodic table, ionization energy, and electronegativity to fully understand why atoms form compounds. Electron trends in the periodic table trends down a group. The number of outer shell electrons is the same. The number of complete electron shells increases by 1. The number of group is the same as the number of electrons in the outer shell of elements in that group, except for group 8. Trends across a period. The number of outer shell electrons increases by 1. The number of complete electron shells stays the same. The point at which a new period starts is the point at which electrons begins to fill a new shell. Let us find out more about the electrons and group in the periodic table. Group 1. Alkaline metals. Group 1 elements have 1 electron in their outer shell. Atoms lose this electron to obtain a full outer shell. This means they become positive ions with a positive 1 charge. Group 1 elements become more reactive down the group. Group 2. Alkaline earth metals. Group 2 elements have 2 electrons in their outer shells. Atoms lose these electrons to obtain a full outer shell. This means they become positive ions with a positive 2 charge. Group 2 elements become more reactive down the group. Group 3 elements have 3 electrons in their outer shell. Atoms lose these electrons to obtain a full outer shell. This means they become positive ions with a positive 3 charge. Group 4 elements have 4 electrons in their outer shell. Atoms don't like to lose their electrons but instead share them covalently with other atoms to obtain a full outer shell. Group 5 elements have 5 electrons in their outer shell. Atoms gain 3 electrons to obtain a full outer shell. This means they become negative ions with a negative 3 charge. Group 6 elements have 6 electrons in their outer shell. Atoms gain 2 electrons to obtain a full outer shell. This means they become negative ions with a negative 2 charge. Group 7 elements have 7 electrons in their outer shell. Atoms gain 1 electron to obtain a full outer shell. This means they become negative ions with a negative 1 charge. Group 7 elements become more reactive up the group. Group 8 elements have a full outer electron shell. Atoms do not need to lose or gain electrons to obtain a full outer shell. This makes a group 8 elements very unreactive, stable, or inert. Next, periods. Period 1 elements only have 1 electron shell. Period 2 elements have 2 electron shells and the inner one is full. Period 3 elements have 3 electron shells and the inner 2 are full. Period 4 elements have 4 electron shells and the inner 3 are full. Period 5 elements have 5 electron shells and the inner 4 are full. Period 6 elements have 6 electron shells and the inner 5 are full. And period 7 elements have 7 electron shells and the inner 6 are full. Now let's proceed to ionization energy. Ionization energy is the energy needed to pull or remove one or more electrons from a neutral atom. The lower the ionization energy, the easier it is to remove its valence electrons. This shows the first ionization energies of some elements. Now, how does ionization energy increase? As you go down a column, ionization energy decreases. As you go down, atomic size is increasing, means less attraction, so it is easier to remove an electrons. As you go across a periodic table, ionization energy increases. As you go left to right, atomic size is decreasing, meaning more attraction, so more difficult to remove an electrons. Also, metals want to lose electrons, but non-metals do not. Why does ionization energy increase the way it does? Increases left to right. Atoms want a full valence shell. They don't want to give away their electrons if they are almost full. Increases bottom to top. Electrons are closer nucleus, so they are being held onto tightly. Electronegativity. Did you know that electronegativity is a measure of tendency of an atom to attract electrons? The higher its value, the higher its tendency to attract electrons. Electronegativity is a measure of the ability of an atom in a chemical compound to attract electrons from another atom in the compound. Now, what is the pattern? As you go down a column, electron affinity decreases. As you go down, atomic size is increasing, so less attraction of electrons to the nucleus. As you go across a periodic table, left to right, electron affinity increases. As you go left to right, atomic size is decreasing, so the electrons are more attracted to the nucleus. Why does electronegativity increase the way it does? It increases left to right because atoms are closer to filling valence shell, so they really want more electrons. And it increases bottom to top because electrons are closer to nucleus. It can pull harder on electrons. The illustration shows the trends in electronegativity. It increases across period left to right and decreases down group top to bottom. Taurine is the most electronegative element and francium is the least electronegative element. Now fill in the table with the given information. The first atom is given as a sample. Refer to the given illustration of ionization energy and electronegativity. You may pause the video to answer this. Now here's the answer. Based on the table, what kind of element has the following? Less than 4 valence electrons, B. More than 4 valence electrons, C. Low electronegativity, D. High electronegativity, E. Low ionization energy, and F. High ionization energy. Answer: A. Metals, B. Nonmetals, C. Metals, D. Nonmetals, E. Metals, and F. Nonmetals. Well done! Now that you already understand valence electrons, electronegativity, and ionization energy, let us proceed to the next activity. The information from the previous activity will be a great help in understanding chemical bonding. Atoms always strive to attain stable arrangement of electrons. They can only become stable if their valence electrons have the same arrangement as that of the noble gases, having 8 valence electrons except helium. Based on the octet rule, elements gain or lose or share electrons to achieve the electron configuration of the nearest noble gas. Thus, after chemical bonding, elements become isoelectronic, means the same electronic configuration with the nearest noble gas in the periodic table. Chemical compounds are created when two molecules join together because of a chemical reaction, and these compounds come in two distinct forms, ionic and covalent. These types of compounds contain many structural differences and properties that distinguish them from one another, but one of the most basic is the types of bonds that hold them together. Knowledge about the type of bond will help you relate the basic properties of these compounds. What are bonds? Elements are the simplest substances that exist on Earth. Each element is made up of just one type of atom, usually joined to other atoms of the same element by bonds. These form molecules such as chlorine or Cl2. Compounds are formed when different elements chemically react and form bonds with each other. Some compounds, like water, have small simple structures with just a few atoms bonded together. Other compounds, like DNA, have large complex structures containing thousands or even millions of bonded atoms. Why do atoms form bonds? The basic answer is that atoms are trying to reach the most stable state that they can. Many atoms become stable when their valence shell is filled with electrons, or when they satisfy the octet rule by having 8 valence electrons. If atoms don't have this arrangement, they want to reach it by gaining, losing, or sharing electrons via bonds. The atoms of noble gas have completely full outer shells and so are stable. This makes the noble gases very unreactive, and so they do not usually form bonds. The atoms of other elements have incomplete outer electron shells and so are unstable. By forming bonds, the atoms of these elements are able to have filled outer shells and become stable. What are the types of bonding? Different types of bonds are formed depending on the types of atoms involved. We have ionic bonding. It occurs between metal and nonmetal atoms. Covalent bonding. It occurs between nonmetal atoms only. And metallic bonding. It occurs between metal atoms only. All bonds involve electrons, and all bonding involves changes to the number of electrons in the outer shells of atoms. How do you think electrons are involved in ionic bonding? Let us consider a very familiar substance, salt. It is the combination of sodium, a metal, and chlorine, a nonmetal. Sodium is a reactive metal found at the leftmost part of the periodic table, and chlorine, a reactive nonmetal found at the right part of the periodic table. Do you know to what family do the most reactive metals and most reactive nonmetals belong? Yes! Sodium falls under family 1, or 1A, in the old classification, and chlorine in the family 17, or 7A in the old classification. When these two reactive atoms combine, salt will be formed, and it is an example of ionic compound. But how are these ionic substances were formed? Let's unscramble the words about ionic bonding. An ion made up of group of atoms rather than one single atom. The correct answer is compound ion. 2. the electrostatic force of attraction between oppositely charged ions? The correct answer is ionic bond. 3. An element that has a full outer electron shell and so is very stable and unreacted. The correct answer is noble gas. 4. A strong force that joins atoms or ions together in molecules in giant lattices. The correct answer is bond. 5. A compound made up of ions. The answer is ionic compound. 6. An atom or group of atoms that has lost electrons and so has a positive charge. The answer is positive ion. 7. A giant 3D structure of closely packed oppositely charged ions. The right answer is ionic lattice. And last, number 8. An atom or group of atoms that has gained electrons and so has a negative charge. The correct answer is negative ion. Now, what is ionic bonding? Compounds that contain ions are called ionic compounds. These compounds are usually formed by a reaction between a metal and a non-metal. Why do these substances react together and form bonds? The metal and non-metal atoms have incomplete outer electron shells and so are unstable. Electrons are transferred from each metal atom to each non-metal atom. The metal and the non-metal atoms form ions with completely full outer shells and become stable. The positive and negative ions are strongly attracted to each other. This electrostatic attraction is called ionic bonding. How are ionic bonds formed? Sodium chloride is an ionic compound formed by the reaction between the metal sodium and the non-metal chlorine. Sodium has one electron in its outer shell. By losing this electron, it has a filled outer shell and forms a positive ion. We have 2 electrons in the first energy level, 8 electrons in the second energy level, and 1 electron in the third energy level. Chlorine has 7 electrons in its outer shell. By gaining an electron from sodium, it has filled outer shell and forms a negative ion. Sodium becomes a cation as it loses an electron and transfers to the chlorine atom. Chlorine gaining the electron becomes an ion, and eventually an ionic bond is formed holding these ions together. The positive sodium ions and the negative chloride ions are strongly attracted to each other. It is the electrostatic attraction that forms ionic bonds in sodium chloride and other ionic compounds. Ionic bonding happens between metals and non-metals. For complete transfer of electrons to happen, the electronegativity difference of the metal and the non-metal should be more than 1.7. The metallic element with low electronegativity loses electrons to become cation, or positively charged ion, whereas the non-metallic element with high electronegativity value accepts those electrons to become an ion or negatively charged ion. Ionic bond requires an electron donor, often a metal with low electronegativity, and an electron acceptor, a non-metal with high electronegativity. Ionic bonding is observed because metals have few electrons in their outermost orbitals. By losing those electrons, these metals can achieve noble gas configuration and satisfy the octet rule, having 8 valence electrons. Similarly, nonmetals that have close to 8 electrons in their valence shells tend to readily accept electrons to achieve noble gas configuration. In ionic bonding, more than 1 electron can be donated or received to satisfy the octet rule. The charges on the anion and cation corresponds to the number of electrons donated or received. Let's have another example, the magnesium oxide. Remember that ionic compounds is a product of ionic bonding. It is the complete transfer of valence electrons between atoms. Valence electrons are the electrons directly involved in forming bonds to form compounds. It is important that you know the number of valence electrons that you can illustrate how bonds are formed. You can use the electron configuration in getting the valence electrons of elements, or you can look at the group number of the elements in the periodic table. Group number is the same as the valence electrons of the elements. Now, how do magnesium and oxygen bond to form a magnesium oxide? What are the electron configuration of the magnesium and oxygen? To form a magnesium oxide, the two elements must exchange electrons to complete their outer electron shells. We have 2A2. Electron configuration of magnesium means 2 electrons in first energy level, 8 electrons in the second energy level, and 2 electrons in the third energy level. And 2,6 electron configuration for oxygen means it has 2 electrons in the first energy level and 6 electrons in the second energy level. 2 electrons are transferred from magnesium to oxygen. This creates a positively charged magnesium ion and a negatively charged oxide ion. These ions then attract each other. An electrostatic force is created between the two ions, and this is called an ionic bond. Millions of positive ions and negative oxide ions join together by ionic bonding to form a 3D lattice. What is an ionic lattice? In a ionic compound, millions and millions of ions are packed together in a regular cubic arrangement joined by ionic bonds. These form a giant 3D structure called ionic lattice. The ionic lattice will continue to build in this way until there are no more ions left to add. The structure of the ionic lattice affects the properties of the ionic compound. This time, let's proceed to covalent bond. Covalent compounds are formed from the chemical combination of two or more non-metallic elements. Table sugar or sucrose is an example of a covalent molecular compound. It is a combination of carbon, hydrogen, and oxygen atoms. In a covalent compound, atoms of the different elements are held together in molecules by covalent bonds. Covalent bonds share their valence electrons. A molecule is the smallest particle of a covalent compound that still has the properties of the compound. Let's unscramble anagrams about covalent bonding. 1. A covalent bond in which each atom shares one of its electrons. The correct answer is single bond. 2. A structurally different form of an element with different physical properties. The right answer is allotropy. 3. A strong bond between two atoms in which each atom shares one or more electrons with the other. The correct answer is covalent bond. 4. A solid substance made of molecules held together by weak forces of attraction, forming a lattice. The right answer is molecular solid. 5. A compound containing atoms joined by covalent bond. The correct answer is covalent compound. 6. A 3D structure containing millions of atoms or ions bonded together. The right answer is giant structure. 7. A covalent bond in which atom shares two of its electrons. The right answer is double bond. 8. A small group of atoms which are held together by covalent bonds. The right answer is molecule. And last, a covalent bond in which each atom shares 3 of its electrons. The correct answer is triple bond. What is covalent bond? Non-metal elements usually just need 1 or 2 electrons to fill their outer shells. So how do they form bond? The two non-metal atoms cannot form a bond by transferring electrons from one to another. Instead, they share electrons. Each atom now has a full stable outer shell. The shared electrons join the atoms together. This is called covalent bond. Covalent compounds are products of covalent bonding. It is the sharing of electrons between atoms. This type of bonding occurs primarily between nonmetals. However, it can also be observed between metals and nonmetals. For covalent bonding to take place, the electronegativity difference of the element should be less than 1.7. If atoms have similar electronegativities, covalent bonds are most likely to occur. Because both atoms have the same affinity for electrons and neither has a tendency to donate them, they share electrons in order to achieve octet configuration and become more stable. How is covalent bond drawn? A covalent bond consists of a shared paired electrons. This is a covalent bond. Only outer shells of electrons are involved in bonding, so the inner shells do not always have to be included in diagrams. Two common ways to represent a covalent bond are simplified dot and cross diagram and solid line. Covalent bonding in hydrogen. Many nonmetal elements such as hydrogen exist as simple diatomic molecules that contain covalent bonds. How is covalent bond formed in hydrogen? Each hydrogen atom needs one more electron in its outer shell, and so each atom shares its single unpaired electron. This shared pair of electrons forms a covalent bond and so creates a diatomic molecule of hydrogen. Some molecules contain double or triple bonds. How are these formed? Bonding in lone pair. Electrons that are shared by atoms are called bonding pairs. Electrons that are not shared by atoms but belong to a particular atom are called lone pairs, or also known as non-bonding pairs. When two atoms share one pair of electrons, it is called a single covalent bond. When two atoms share two pairs of electrons, that result is called a double covalent bond. When two atoms share three pairs of electrons, the result is called a triple covalent bond. We have 6 electrons. How do elements bond? What are the types of covalent bonds? Many nonmetal elements exist as diatomic molecules with covalent bonds. These molecules can be bonded by single, double, or triple covalent bonds. This animation shows how covalent bonds form between atoms of different elements. Chlorine needs one more electron to have a completely full outer shell. To achieve this, it can share an electron with another chlorine atom. This creates a single bond. Oxygen needs two more electrons to have completely full outer shell. To achieve this, it can share two electrons with another oxygen atom. This creates double bond. Nitrogen needs 3 more electrons to have a completely full outer shell. It can share 3 electrons with another nitrogen atom to do this. This creates a triple bond. Can compounds contain covalent bonds? Covalent bonding can also occur between atoms of different nonmetal to create molecules of covalent compounds. These covalent bonds can be single, double, or triple. How is a covalent bond formed in a hydrogen fluoride? Hydrogen and chlorine both need one more electron to fill outer shells. By sharing one electron each, they both have a stable outer shell and a covalent bond is formed. Covalent bonding in water. Compounds can contain more than one covalent bond. Oxygen needs 2 more electrons, but hydrogen only needs 1 more. How can these 3 elements be joined by covalent bonding? The oxygen atom shares 1 electron with 1 hydrogen atom and a second electron with another hydrogen atom. What is the name of the molecule that is formed? Yes, H2O or water. There are 2 types of covalent bonds, polar and nonpolar bonds. Atoms can share their electrons equally or unequally. Polar covalent bond. Polar covalent bonding is a type of chemical bond where a pair of electrons is unequally shared between 2 atoms. In a polar covalent bond, the electrons are not equally shared because one atom spends more time with the electrons than the other atom. In a polar covalent bond, one atom typically has a negative charge and the other has a positive charge. One atom has a stronger pull than the other atom and attracts electrons. The electronegativity difference between the elements should be 0.5 to 1.7 for polar covalent bond to happen. Some examples of polar covalent bonds are water, ammonia, and sulfur dioxide. Non-polar covalent bonds are a type of bond that occurs when two atoms equally share a pair of electrons with each other. These shared electrons glue two or more atoms together to form a molecule. The electronegativity difference between nonmetals should be 0 to 0.4 for non-polar covalent bond to happen. Examples of non-polar covalent bonds are the diatomic molecules hydrogen gas, nitrogen gas, oxygen gas, chlorine gas, bromine, and iodine. You can determine the type of bond between two atoms by calculating the difference in electronegativity values between the elements. The bigger the electronegativity difference, the more polar the bond. If the difference in electronegativity between bonded atoms is 0, the bond is pure covalent, means equal shaping. If the difference in electronegativity between bonded atoms is 0.1 to 0.4, the bond is non-polar covalent bond. If the difference in electronegativity between 0.5 to 1.9, the bond is polar covalent. And if the difference in electronegativity between bonded atoms is larger than 2.0, it will be 100% ionic bond. Remember that the greater the difference in the electronegativity between two atoms, the more polar their bond is. For example, the electronegativity difference between two chlorine is 0, so it's non-polar covalent. The electronegativity difference between hydrogen and chlorine is 1.9, so it's polar covalent. And the electronegativity difference between the lithium and chlorine is 3.0, so it means it's ionic. Now it's your turn to practice. Refer to the given values of electronegativity in the earlier discussion. Calculate the electronegativity difference and give the kind of bond that exists between the atoms in each pair. For example, what type of bond is HCl? We have 2.1 electronegativity of hydrogen and 3.1 electronegativity of chlorine. Its electronegativity difference is 1, so therefore it is polar covalent bond. You may pause the video to answer this. Now here's the answer. Number 1, the electronegativity difference is 2.3 and the type of bond is ionic. 2, 1.9, polar covalent. 3, 1.4, polar covalent. 4, 0, non-polar covalent. And number 5, 0.5, polar covalent. To gain more understanding about the lesson, this activity is provided for you. Read and analyze them well so that you will arrive on the right answer. A. Ions and ionic bonding. Complete these sentences about ionic bonding. Number 1. When atoms lose or gain electrons, they become blank. 2. Atoms of blank lose electrons to empty their outer electron shell and become blank ions. 3. Atoms of blank gain electrons to fill their outer electron shell and become blank ions. And blank is a force of attraction between oppositely charged ions. Ions cluster together to form a giant ionic. And number 5, the ratio of metal ions to non-metal ions in an ionic compound will depend on blank loss and gain. The correct answer for number 1 is ion, number 2, metal and positive, 3, non-metals and negative, 4, ionic and lattice, and number 5, electrons. B. Covalent bonds, true or false? Are these statements about covalent bonds true or false? 1. Atom bonds so that their outer electron shells become half full. 2. Covalent bonding occurs between nonmetals. 3. A single covalent bond is a shared pair of electrons. 4. Covalent bonds only occur in compounds. 5. Oxygen molecules contain a double bond. And 6. Most substances made up of simple covalent molecules are solid at room temperature. And here's the correct answer. Number 1 is false, 2 true, 3 true, 4 false, 5 true, and 6 false. Let's remember, what are the differences between covalent and ionic bonding? Covalent bonding occurs between nonmetal atoms, Electrons shared does not involve charged particles. Ionic bonding occurs between metal and nonmetal atoms. Electrons lost or gained and involves charged particles. Check your understanding. Answer the following. Write your answer in your notebook. Direction. Determine if compounds are ionic compound or covalent compound based on their elements combined. Write I if the compound is ionic and C if covalent. For example, sodium chloride or NaCl. Sodium is a metal and chlorine is a nonmetal, so it's ionic compound. So the answer is I. Number 1, barium chloride, 2, carbon dioxide, 3, aluminum nitride, 4, sodium hydroxide, 5, oxygen gas, 6, water, 7, magnesium bromide, 8, carbon tetrachloride, 9, ferrous sulfide, and number 10, nitrogen gas. You may pause the video to answer this. Chemical bonding is one of the most basic fundamental of chemistry that explains other concepts such as molecules and reactions. Without it, scientists wouldn't be able to explain why atoms are attracted to each other or how products are formed after a chemical reaction has taken place. So that's the end of our lesson. I hope you learned something new today. Watch out for the next video lesson in science. Answer the questions and activities in your module appropriately. Don't forget to like, share, and subscribe. This has been your teacher, Rosalie Custodio, saying, learning science is fun, cool, and awesome. Until next time, students, thank you for watching and have a nice day.